Okay, so as you look up at these, you can pick a specific color that you want to work on. We got red, I don't know if you call that a light blue or green, a green one, and a brown one. So there's four. Um, okay. So when you see the name, means you have to draw out the structure. So what organic family are we dealing with? Okay. So that means somewhere in that compound there is a what? Okay. So how many carbons are there? Okay. So we can safely draw out these 7. Okay. So again, here's our organic family. We've got our 7 carbons. Okay. What's that 2 telling you? Okay. Okay, and then what do we see here on the 3rd one? Okay. So upon doing that, we'll stretch them out a little bit. Go ahead, put all of these bonds in. Okay, so what do we have to do to finish that? We say isopropyl, but you want to do that in a specific manner. Well, how many carbons are in an isopropyl group? Okay, so how are those 3 attached? Okay. Okay, there's your isopropyl group. That is right. Okay, so we've accounted for everything. There's 7 carbons. There's a double bond after the second one that we've established there. And so organic family, 7 carbons. After the second one, there's a double bond. And on the 3rd one, there's an isopropyl group. So all of them are on there. Okay. Okay. Go ahead and erase. I think we'll use this as our workspace over here. Okay. So what is significant about this one that's written in green? It's a ring structure with how many sides? Okay. So is there any multiple bonds in this 6-sided figure? Okay. So if we just left it with that, what do we have? You'd have cyclohexane. There's no double bonds in there. Okay. So why is it that these numbers are not written in increasing orders? Because you're putting them in alphabetical order. That's correct. So where do you want number 1 to be? Okay. So an ethyl group has a formula of what? Okay. You believe that? You really believe it? Okay. All right. Really, really, really believe it? Okay. All right. Okay. Okay, so are we going clockwise or counterclockwise? Okay? So straight across from here, we've got what? Okay? And then, do we have to go left or right now? Clockwise or counterclockwise? Does it matter? No, it does not matter. In this case, it does not. So you said left. So how many carbons do I put on here? And how are they arranged on there? Okay. Do we have to write a structural formula, or can we write a molecular formula? Okay. We can just do C3H what? Okay. Now it's different. You can write a molecular formula for an isopropyl group. It's a little different. It's probably a little more confusing. So at this level, I think it's more important to just write it as a structural formula rather than molecular type. Okay. So that is correct. So what do you think is easier? I would be led to believe if you see the name of the compound, it's probably easier writing it as opposed to when it's already written, then you have to decipher what the compound really is. Would you agree with that? Okay. So can we erase that cyclohexane? The only thing that would change, okay, and what would happen if you put something like that in there? Okay, and then what we would see is number 1 carbon's actually down there. Okay, all right. Okay, so upper right or lower left? Okay, so lower left. What is your parent chain? Okay. That might not be enough room. Heptane. Okay. So what's branching off of that heptane? Is that right? Really? I hear heptane, I hear octane, I hear nonane. Well, are we sure? Okay. All right. Okay. Is anyone confused on how or why it's nonane? Yes? No? It is nonane. Okay. So, and otherwise, we're always open for you individuals to come up here with examples. Yes? No? Maybe we can do that afterwards. You can quiz each other. Are we doing all right so far? Because we don't want to bore anybody. No? That's not happening? We just don't want to say anything. That playing Fortnite cuts into the old sleep time. I don't know if you are. Okay? Okay, so typically the first thing that you would possibly do, okay, you might go 1, 2, 3, 4, 5, 6, 7, maybe. Well, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Well, 1, 2, 3, 4, 5, 6. That's not right. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we have our nonane. So what we need to determine then Does it go like that? In other words, in that direction? Or does it go over in that direction? Okay? Well, in other words, does it go down, over, and up, or does it go down, over, and up that way? That's what we're trying to illustrate with that little diagram there. Well, in order to do that, okay, well, find where your first derivative is. You either pick one side or the other. You want to go left or right to start out with? Right, okay? So 1, 2, 3. Our first one is on number 3, okay? So 3. What about on here? We got 5 and 5, okay? And what about this? 6, okay? Well, what happens if we try going the other way? 1, 2, 3. Here we've got 4. What about these two? 5 and 5. 6 and 7. So, do 3, 5, 5, and 6 work? Or we want 4, 5, 5, and 7? 3, 5, 5, 6. Is anyone confused about that? Do we see why it is the blue and not the orange? The lowest combination, okay? So we can take these orange ones out. And sometimes when we write these, we really don't know. We just have an idea of it's going like this, but we just decipher, well, let's throw some derivatives on there. Because if we work on it together and it's a fairly difficult one, well, then chances are we'll be all right for tomorrow. Okay? It's not the only group. See, Liberty is on the move. In case someone's wondering what I'm doing, you know, speaking into my Liberty is on the move. See, I'm telling the other Secret Service agents that the president, or maybe it's Eagle is moving, or whatever code word President Trump uses. So, and maybe you're not even listening to music, but that's the first thing that goes through a person's mind. You are, all right. Or we just like them hanging in our ears. Right? All right. All right. Yes. Because if there's nothing written after that number, like there is here, it's not saying there's a derivative, it's not saying there's anything other than where that double bond is located. Okay. All right. So, on our third carbon, there's a what group? There's a what group? Oh, I thought you said propyl. That's why I said what? Okay, so we have a methyl group. What do we have here? We have a methyl and a methyl. And then what about here on number 6? We have an ethyl group. Okay, so we have our numbers. Okay, 3, 5, 5, and 6. We just need to put them in alphabetical order now. So, which one is coming first? Okay, so 6 dash what? Dash. Sure? Okay. So 3, comma 5, comma 5. Okay. We got a methyl group there, right? Are we just saying yep, or do we really understand? Okay. Okay, you're getting the, you agree that these are methyl groups, right? Okay. All right. So, see, we're calling this X marks the spot, right? That carbon. So we're going to say that that carbon is right here. So, branching off of that is this guy. So the formula, so CH3 means it's a what? Okay. Now, if this says X marks the spot, what's that guy? Okay, and X marks the spot for this one. So remember, these are carbon to carbon bonds. That's not hydrogens. Okay, so when we do that, oops, now we see that we've got 3 methyl groups. Where are those methyl groups located? On the 3rd, the 5th, and the 5th. So now that we know that we've got 3 methyl groups, this tells us where they're at, and the prefix for 3 methyls is what? All right. So it just happens to work out this way. Which are we using in alphabetization? This letter or that one? The T or the M? You use the M. The exception for prefixes for derivatives is which letter? I for isopropyl. Okay? So, in other words, yes, we disregard the T, we go by the M. We don't use prefixes in alphabetizing. Only the I in isopropyl or isobutyl. But we don't have isobutyl groups on there, unless you want them. Okay. So remember, and when you're looking at these, you can always go backwards, because you had said that once you have, if you have the word, it's so much easier writing the structure out. Well, this tells you your organic family again. That is an alkane. So all the carbons are single bonded in there, and they are. This tells you how many that you have, okay? This says you've got a methyl group, but not just one. There's 3 of them on the 3rd, the 5th, and the 5th. Well, here's number 3. Here's one of them on number 5. Here's the other one on number 5. And then on an ethyl group, which was C2H5, which is right here, there's your ethyl group, C2H5. All right, so then finally, we've got the last one up there on top. Okay, so your parent chain is what? It's a tricky one. Okay, the reason, why is this a trick question? Correct. Because if you do this, okay, if you go up and to the right, okay, you're not accounting for that organic family. Okay, this is one of the exceptions to where typically you have to have an ethyl group on the 3rd carbon or greater. In this case, this one's past the 3rd carbon. But again, your longest continuous chain here is only 4, because you have to include that with your organic family because it's an acid. Okay, so branching off of that parent chain of 4 is a what group? It's an ethyl group on which carbon? Okay, so 2-ethyl dash butanoic acid. Now, you might be asking yourself, do we need to write 1 to account for that? And the answer is no. Because when you say that you have OIC, you're already saying that there's an acid, and it has to be on the first carbon anyway. There is no other way. That does not exist. Why not? How many carbons, how many bonds does that one have? It has 5. Well, you might tell yourself, well, okay, well that's fine. I'll just take this OH off. Well, you haven't accomplished anything. There's still 5 bonds. You're going to say, well, okay, I'll take that hydrogen off. Do you think this is an actual compound? It is, yes. And, let's see, who can I pick on? No, maybe. Go like this. Nope, can't pick on Cole. Go like this.
Oh, I know what it is.
Yes, I can pick on you. Go like that. Yep. Allie's the only one I can pick on. Why? Because you have nail polish on. Okay? So how are you going to, if you don't want to sit there and scrape, I think that might get to be kind of annoying, and maybe even, does it hurt if you do that too? Okay. That is acetone. Yep. Okay. So that's a different category of organic families. We're not going to have ketones on there tomorrow. Okay. Unless you want to call it 2-propanone, which we could, but we're not going to do that. Okay. So that's why if you're going to categorize this as an acid, it's just understood that has to be on the first one. There is no other way to write an acid other than writing it on the very first carbon. Okay? I think that was all of them, wasn't it? Okay. So we could also be doing. Anybody know anything different? Notice anything different about this whiteboard? No, not really. This guy's up there finally. Yeah. It's not on the floor anymore, otherwise it was just leaning up against here. Got to be kind of annoying. So. Oh, yes. Okay. So, what do you think? The bigger the chain or smaller the chain? Which would you rather have? Okay. Good. Five what? 5 carbons? Okay. Is it an alkane or an alkene? Okay. All right. So we got C5H12, correct? That is pentane. The simplest way to write an isomer of pentane is do what? Take this one off and do what? Okay, so we still have C5H12, but it's no longer pentane, it's 2-methyl what? 2-methylbutane. Would we agree with that? Okay? Yeah, you can still count them. 4 and 1, right? There's 5. How many hydrogens? 3, 5, 6, 9, and 3 more is No. Butane. Okay? So that's one isomer. Well, how about we just take that and move them over one? No. Yeah, that's still the same thing. Well, let's take them off the end and put them here. That's still pentane. Okay? Well, taking one off isn't working, so I suppose let's take two of them off. That's the same thing as what? That is 2-methylbutane. Yes, it is. No, it is not an isomer. Yep. There you go. Yes, that is correct. So typically that's why I said you want a lot of carbons or a small number. So when you pick the smaller number, it's actually more difficult. But we like things more difficult. You go right ahead. Okay. So there's also halogen derivatives, cycloalkenes, cyclopropene. That's correct. Okay? So we're lucky it really doesn't matter which way well, it does kind of matter. Because this has to have the first carbon. So if that is the case, does it go 1, 2, or 3? Or 1, 2, or 3, so it really doesn't matter. So you've got a methyl group on which one? On the third one. So in this case, you have 3-methyl dash what? Cyclopropene. Yep. And in case you're wondering, do you have to have a 1 after this? And the answer to that is no. Okay? Because it would just be understood that it has to be after the first carbon. So if you're going this way, it's still number 3. Going this way, it's still number 3 as well. Okay? I guess you probably don't need one, no. Oh, that works. Okay. Left outside, left middle, or excuse me, right middle, left middle, right outside. Are we just saying that, or are we actually good? Okay. Is there anything else? Okay. So, ready to go for tomorrow. Next week we will set up your semester review. Okay. How many of you did you like what you did last semester for that semester review? We'll catch up to you next time. So.